All right, we're on page 413. We're starting on lesson 20. We are skipping lesson 19 because lesson 19 and lesson 20 are very similar. And we want to try to get spinning up a little bit, kind of get caught back up to where we need to be at, all right?
Okay.
So we're skipping lesson 19 and going to lesson 20. They both deal with adding and subtracting fractions, though. So if you guys do need any extra practice adding and subtracting fractions, you probably can go back to lesson 19, right, and get more additional practice, correct? So I'm going to zoom this in so you guys can actually see the screen a little more. I know I've heard a lot of complaints with that, seeing things. And here we go. All right, so session 1, explore adding and subtracting fractions. Our learning target today is we're going to decompose a fraction into a sum of fractions with the same denominator in more than one way. Recording each decomposition by an equation, justify decompositions by using a visual fraction model. That's a mouthful, isn't it?
Yep.
We're going to probably what's one vocab word you see here, like 4 times?
What's a vocab word?
Like a word that you don't understand, and you think it's kind of important that we don't understand what it means. We're probably going to learn.
That's like
Raise your hand, please. What?
It's the D word and like.
The decompose and decomposition.
Yeah.
We're going to talk more about that word, right? So, and we're also going to solve word problems involving addition and subtraction of fractions, referring to the same whole and having like denominators. All right? Kind of a mouthful. So more or less what this is saying, we're going to be adding and subtracting fractions and equations using series different ways, right? So let's go back and let's find out how we did on this in our diagnostic test, all right? So we go back.
Wait, we have another diagnostic.
No, we're going to go off and see how we did on it in our diagnostic, remember? So we can compare where we were at last January to where we're at now and see what we need to learn. So it's NF, I believe it's NF2. Creating common denominators. Here's fractions, different numerators, different denominators. No. Here, this one right here. Numbers, decompose a fraction into the sum of fractions with the same denominator in more than one way, recording each decomposition by equation. This is the same standard that we're going to be learning this week. Remember, we talked about the green check mark means you have it, you have a complete understanding of it. The clear check mark, let's get turned to our class. The clear check mark means you partially understand it. The X means you don't understand it at all. So, in January, when we took the diagnostic test, a whopping 0 students understood this standard. None of you did you?
No.
4 of you had somewhat of an idea. Somewhat. That means probably not the best, right? 15 of you had no idea. So, should we probably pay attention and really focus on this week's lesson?
Yes.
Yeah, we got to put some time towards this so we can get that number upped, right?
Yep.
All right. So let's go back to the PowerPoint. From current slide. So, let's use the warm-up. Use 1/12 to build one whole. Complete the equation to show how you made one whole. So what are we doing here? Adding 2 fractions to equal one whole. What does one whole look like when it's over 12?
Want to be 6,
Michael?
12,
12 12s, right? So one whole equals 12 12s. What are we going to add up to equal 12 over 12? Amelia? 6 over 12 and what?
6 over 12.
Yeah, could I just add 6 over 12 plus 6 over 12?
Yes.
Yeah. I hate when it does that. Yeah, why can't I just do 6 over 12 plus 6 over 12 equals one whole, or which is the same thing as 12 over 12. Does that add up? Yeah, 6 plus 6 equals 12. When we add fractions, we just add the top numbers. We don't do anything. If the bottom numbers are the same numbers, they just stay the same. Does that make sense? We'll talk more about why it happens that way here in a minute. But that's what you need to understand. So, who wants to read this question? I'm starting on page 413. Oh, Caden, go ahead and read it.
Lynn, Paco, and Todd share a pack of 12 cards. Lynn gets 4 cards, Paco gets 3 cards, and Todd gets the rest of the cards. What fraction of pack does Todd get?
So, Lynn, Paco, and Todd share a pack of 12 cards. Lynn gets 4 cards, Paco gets 3 cards, and Todd gets the rest of the cards. What fraction of the pack did Todd get? What is it? What are they all going to be over? Huh? Not over 1 whole. What are they all going to be over? What's the denominator going to be for all these fractions?
The denominator?
What's the denominator going to be, Michael?
12.
12, because it's out of a pack of, the whole is 12, right? With that being said, go ahead and figure out how many Todd has. What fraction of the of the whole pack Todd has. I'll give you about, I'll give you
So do we add
3 minutes for you to figure out right now. You got to figure out how many Todd and Lynn and Paco have, right?
You can't see the red.
Hmm?
You can't see the red.
Oh, yeah, I'll remember that. Thank you for reminding me. You have to use the highlighter. Thank you.
How come all of them have 4?
Those. Make it up.
How come all of them just have 4?
Because they don't. Because it's not what they have. Lynn got 4, Paco got 3. You gotta do what the story problem tells you. You don't get to make up your own problem, do you? Alright, so what do we got to figure out first? Amelia?
How many cards Todd gets?
How many cards? That's what we got to figure out at whole, right? We got to figure out how many cards Todd gets. What do we got to figure out first, though, to solve for how many cards Todd has? Yes? Cool.
Add 4 plus 3, see how much that
What are the 4 and 3?
It's 7.
It is 7, but what does 4 and 3 represent? You're right. What does 4 and 3 represent, Jacob?
Don't they represent the numerator?
Well, they're going to be, yeah, they'd be numerators. But what is 4 and 3? Nolan?
How many cards
Yeah, we got to add up how many cards Lynn and Paco got, right?
You just.
Oh. We got to add up how many cards Lynn and Paco have, right? So, we're going to take 4 You're going to take 4 plus 3, and you equal 7, right? 7 out of how many? 12, right? So Lynn had 4 cards out of how many?
12.
So wouldn't this really be 4 over 12?
Yeah.
And Paco had 3 out of how many?
12.
So together they have 7 out of
12.
12. Or 7 12s, right? So we figured out how many they have. How do we figure out now how many Todd gets with what we have? Orion?
Todd gets 11.
How did you figure that out?
A minus 4 and 3.
You wouldn't subtract 4 and 3. How do you find out how many cards Todd has with knowing how many they have? Sid?
Subtracting 12 and 7.
Yeah, you do 12 minus 7. Or 12 out of what? 12 out of 12 minus 7 out of what?
12.
12 equals 5 out of 12. So Todd gets a total of 5 cards out of 12 cards. Does that make sense? How many got that? Raise your hand if you got that.
I got 5.
5 cards or 5 out of 12, right?
I got 5 out of.
Because remember it asked what?
What the
What fraction of the pack does Todd get? Did it ask how many cards he had? No, so you got to figure out the fraction. So you got to figure out the total of how many you got over the how many that was possible, right? So it asked for a fraction, so you better answer with a what?
With a fraction.
You better answer with a fraction if it asks you to answer with a fraction, right? Yes, Jay.
Well, I did 4 times.
Hang on, don't tell me how you did it. We're going to talk about that in a second. Yes, Nolan.
It's about the 9. Like, what? There was 4, 7, and 3, 15.
Next year.
Aw.
You're going to define common denominators. You're going to define equivalent fractions to each one that share a denominator, and then do it. Does that make sense? That's how you do that. But that's the next year question. You guys will do that in 5th grade. So I want you to turn, now that you guys saw it, I want you to turn and ask your partner, why did you choose that strategy? So ask your partner how they solved it. You saw how I solved it, ask your partner. You two can go together. Cool to me.
I did 3 plus 4. I did solve the 7. I counted it up from my way to 7. I did the subtraction. 8, 9, 10, 11, 12. So I did 12 plus 8. 12. Take away 3.
How'd you guys do it?
And then I put 9 together.
Oh, and then you circle 4 and then 3 and then count how many cards are left? You good? Alright. So number 1 on the next page, looking back. Explain how you can find the fraction of the pack that Todd gets. What did you need to do first? Amelia?
You had to see how many Lynn and Paco had together. How many cards they had together.
So you had to first find out how many Lynn and Paco have, right? So that's what you did first. What did you do second? What did you do then? What did we do after that? We found out how many they had, right? And it wound up being 7 cards, right? 7 out of how many?
7 out of 12.
So you want to be 7 out of 12, right? Then what did you do? Someone besides Amelia.
Wow.
Sorry, Amelia, don't mean to like just break your heart like that, but I like other people's voices too. Caden?
You did 12 minus 7.
You did the whole minus 7, right? The total minus 7. Then you subtract the whole, which is what was the whole?
The whole was 12 over 12.
12 over 12. By 7 twelfths, right? That's all we did, right? Is that a multi-step problem?
Yeah.
There was a multi-step there, wasn't there? First we had to figure out how many cards there were, right? Then we subtracted that from the whole. Any questions? Adding and subtracting fractions are pretty simple, really, aren't they? It's just, and when they have the same denominator, you just subtract the numerators. Make sense?
Yeah, but
Yes.
didn't you say that adding and subtracting are harder than
It is if you have different denominators. If your denominators are different, then they become quite a bit harder.
Will we learn that in
Yeah, you'll do unlike denominators, adding, subtracting fractions when you get to 5th grade. Multiplication and division, the denominators don't matter. Adding and subtracting, you cannot add or subtract anything until they have the same denominator. You gotta make them like. But right now, all of ours have been like denominators so far, right? They both are over 12, correct? Okay. Looking ahead, number 2. In the problem on the previous page, the whole is a pack of cards, right? The whole is how many cards were in the deck, or in the pack. Since there are 12 cards in the pack, each card represents 1/12, right? If I have one card, it's 1 out of 12. Does that make sense? Look at the hole shown here. The hole is the pizza. It is a single object, right? Before we were talking about 12 individual cards, right? Now we're talking about the pizza as one whole, correct? How many equal parts are shown in this pizza? How many parts is that pizza divided up into? Not 3. How many pieces are there? 1, we got 1, 2, 3, 4, 5, 6, 7, 8, right? How many parts is that pizza divided up into? 8.
Oh, darn it.
There's 8 equal parts, right? What fraction can you describe to use each pizza? How much is one piece worth of that whole pizza? 1/8, right? One slice represents 1/8. Does that make sense? Because it's one piece out of a total of 8. Understand that so far? You get that? It's one piece out of 8. What fraction can you use to describe the whole pizza? Michael?
8/8.
It's 8/8, right? 8 out of 8. Because there's 8 slices out of a possible 8. So the whole is 8 out of 8. What fraction can you use to describe the 3 pieces being taken away? Cole?
3/8.
3/8, right? We're taking a possible 3 We're taking 3 away out of 8 whole pieces, right? Yes, Nolan.
I did 8 minus 3.
That would tell you how many are left. They wanted to know what fraction can you use to describe the 3 pieces being taken away. You describe the ones being taken away, not how many are left. Does that make sense? Any questions on any of that? That's pretty easy stuff, right? Number 3. How does knowing about equal parts help you add and subtract fractions? How does knowing about the equal parts help you with adding and subtracting fractions? And remember, equal parts is like knowing how many are in a whole. How does that help you with adding and subtracting them? Gabe?
Figures out how much more you have to get to 1 whole.
Yeah, if you can figure out, you know, like how much more you need to get to 1 whole. Because isn't that really all about a fraction is?
Yeah.
It's all about the whole, how much is left to get to the whole, how much more you need to get to 1 whole. Does that make sense? How much I'm taking away from 1 whole? It's all about the 1 whole, right? So that's what the bottom number is. It's just the whole. Any other questions, comments, concerns? Yes, Amelia.
Can you use like a bar, not a bar,
Number line?
yeah, to do this?
Oh, yeah. You could definitely use number line to do this, couldn't you? Think of it like this. I draw my number line. And I draw 1 whole number line, hopefully. I start off here. I have 0. Say I have 1 here. I divide my whole, this is 1 whole, right? I'm going to divide it into 6 pieces. 1, 2, 3, 5. I got 6 pieces, right? What is this first one? This is 1 out of 1 6, right? This is 2 out of 3 out of 6. 4 out of 6. 5 out of 6. And 1 whole is really 6 out of 6, right? Now say I have 2 6, right? I have 2 6 of the, I have, out of the pasta, I'm going to say, I have 2 6 of a pizza. Sid gives me another 2 6 of a pizza. I start at 2 6, 1 6, 2 6. How much do I have left? 4 6. Should I use the number line to add and subtract fractions? Or say I have 3 6 of a candy bar. I eat 2 6 of it. 1 6, 2 6. How much do I have left? 1 6 left. Is that, can I use the number line to add and subtract fractions? Yeah, you can use it. That's the same thing. But does it show 1/8 or not?
Yeah, no. Actually.
1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
But they all broke up the same way? No. Does it show 1/8? No. Alright, so you can work on the green pages 415 and 416. You do not have to do the web. That is all you have to do today, right? Virtual kids, if you have any questions, feel free to email me. Let me know you have questions. This video will be posted on YouTube. We are working on it, and I will see you guys tomorrow. See me tomorrow.
Just turn on the comments. It's so hard to make your pencil.
Yeah?
Hopefully the voice is on.
Ain't off yet.